Good morning, everyone. So we have, before we start with the topic of today, I'd like to have a quick chat about the coordinate systems, etc., that we are also needing to deal with. And so it seems that people are really getting stuck with this coordinates. I'd like to stress that using the diagram is essential. I've updated the slides for lecture 3 where this is now included. Previously you'd only have this picture rather than also the one with boxes. So I've updated that so to make your life a little bit easier. Of course you can draw this yourself, but you do need to actually think about how do you go from one line coordinate to the other one. So if you have this line, what is the box there? What is the box there? Obviously this one doesn't exist. But that's the idea. If you have a horizontal line, what's the coordinates of horizontal line? What's the box above? And what's the box below? You get the idea. What are the formulas? And if you get stuck, you may want to have a go at actually making it bigger in your own drawings. That should really help you. Anyway, that is the bit about this. Let's go to the actual lecture. If you give me a minute to start that up. So that should have the lecture slides for you available again. So today we're going to look at the Android architecture component. By the way, before I forget as well, when asking questions, please use Virtual P201, not just direct messaging me or Kevin, because if we use Virtual 201, we can kind of actually manage the workload among us. Also remember, we do keep office business hours somewhat, so weekend, yeah, asking questions is possible, but you won't really get much help over the weekend. We do have other things in our life than just teaching. So please use that, the system as intended. And you can tag us in Virtual 201 with the unit so that we get the notification. Then we have the question of architecture components. So what is this all about? Well, first I'm going to talk about the architecture components. We'll talk a little bit about things like view binding and data binding. And we're talking about life cycles, live data, and view model. Those are particularly architectural patterns that Android provides to make the developer's life a little bit easier. It's not mandatory, but it can make it really better. And there's the adapter pattern that this time I will actually give before I'm going to go into recycler view that heavily depends upon that pattern. So without further ado, let's go to the architecture component. So when we look at Android, we have the standard Android framework, and this framework actually is included with your phone, so it's tied to the OS version. Every version of the OS has a particular version of the framework attached to it with certain versions of the API tools, etc. Not only that, and that makes that it's guaranteed to be available, and it keeps your applications nice and small because you don't need to bundle the framework with your app. Because it is there for everyone, because everyone has to use it, it is a non-opinionated framework that doesn't force any design choices. But unfortunately, there are some parts that are either design limitations or actually are broken is maybe hard. So they don't do certain things very well, but it's not like they're broken. If they were actually not working at all, they would have been fixed. There's no point in keeping something that is broken around even for compatibility reasons. But the designs are sometimes, say, superseded by further insight. And as a result of these limitations of the standard framework that is kind of attached to your application, what they have done is create the support library. So it started out as a small library with some compatibility, what we call shims. So a shim is basically just a thin wrapper that translates from one thing to another one, but mainly just forwards stuff and then returns the result. So you see those in JavaScript as well, by the way, compatibility shims, where they use JavaScript to kind of implement the same as would happen if you had a modern browser, or for CSS as well. So with these shims, what is the advantage is that you can write one code base that uses new features when they are available, but if they are not, it works without them. Things like, for example, a fingerprint scanner. Not every phone has one, so even the modern version doesn't have it. But if you use a compatibility shim, you can write code that uses fingerprint scanner, even if the version of the API doesn't support fingerprint scanners. Well, when you ask, does it have a fingerprint scanner, it just returns false. So it doesn't implement anything, but your code will not crash because the API is not available. In some cases, it will actually implement a workaround that gets the same behavior, but not as ideally as with the proper version. So the support library has a lot of these compatibility elements implemented in. And at some point, they are also added some new features, and in particularly when we moved from Eclipse to Android Studio, that also included the move from Ant to Gradle. So Ant is a build system, but it doesn't do automatic downloading of libraries. Gradle does this. And as a consequence of doing this, it has certainly become a lot easier to use all kinds of libraries, because it is just adding a line to your Gradle file or even using the editor to do so. That is what Gradle does and what it allowed. So what they at that point found to do was that actually you can create new components and you just make them available in this support library. And there are many advantages of doing so, including the fact that if you do this, you can actually update them as and when you want. For example, a big one is that recycler view. Recycler view was developed as an improvement on list view, which is in the framework, but it was not part of the framework because they found with list view they wanted to fix list view, but they couldn't because it was part of the framework and compatibility requirements, etc. So recycler view is an updated list view, but in many ways better. And over time, this has resulted in the release of, or in the rebranding and release of what they now call Android Jetpack. Android Jetpack is basically all the Android X classes. So there are separate libraries that you include in your project. So you can determine the version that your application will be using. That means that if they create a new incompatible version, you can just stick with the old version. Your app will keep working, but new users can use the latest version of the library and take advantage of that. And you can update to that latest version as and when it's feasible for you. Of course, at some point, if you have that and you use a really old version, at some point it might become the case that your that the old version doesn't support the new OS version, etc. But that normally takes quite some time. They try to take care of not losing too much way. So that's the Jetpack. And as part of this Jetpack, which is not tied to any OS release, so you can use it even to target older phones, because it takes years before people move from older OS versions to the newer ones. Yes, and Google has worked to try to improve this situation, but it is still ongoing. And as part of that, there was also a lot of demand from developers for Google to actually provide more guidance in how you actually create your application. What is a good design for an application? Of course, there's many ways to design an application, but they wanted something that said, okay, this is supported by Google. This is a good way of doing it. And that is what the architecture components basically are. So they are part of the Jetpack, and they provide components that can help you with the design or architecture of your application. Note, in the assignment, we are not using these, and I would strongly advise against trying to retrofit your assignments to make it work. But you can see some of the aspects that the assignment does also come back in these architecture components in a different way. Of course, if you have a new screen that's completely independent, you can use it, but not for your game view. And by the way, I've put lots and lots of links into your into the slides. So if you download the PDF, you can actually just click on those. Not if you do the handouts. The handouts don't have clickable links. I haven't managed to make that work. Because I used a tool to create the handouts that just basically puts 6 of them on one page, but it loses the links. So today we'll be looking at some part of the architecture components, because there are many more. First one of this is the data binding and view binding. So basically the idea that you can actually have a better way of doing this linking between your UI, your layouts, and your code, your Kotlin or Java files. And it also enables the model view model architectural approach as we discussed in the previous lecture. That is where data binding comes. View binding is a lighter weight version of that. We'll come back to that. Then there is the life cycle. So the idea of life cycles is, well, your activities, they have a certain kind of states. They can be created, they can be paused, or etc. So there's all these different states. The same with fragments. So fragments are components you can put inside an activity that have an awareness of their life cycle. So they're not views, because views have very limited ability to add behavior and to participate in this life cycle bit. Views should be rather independent, dumb things. Fragments are more complex. So life cycles are quite important also to make sure that stuff that you don't need is lost. So live data relates to that. So how do you actually update data into a UI? How do you say if you download, if you have a post of someone and there's an image to that, how do you update the image, the post once you've managed to download the image that belongs to the post? And live data does that, and the view model basically allows you to manage this live data and getting access to the data in your application. Again, our assignment doesn't really have too much of that data because we just have a game, etc. But you could extend upon that if you really wanted to. But for our game, it's not needed. So data binding and view binding. So view binding is a simpler version of data binding. So what does view binding do? So view binding is something you just enable in your Gradle configuration, your build.gradle of your app module. Not of your overall project, of your app module where you have this Android bit. You can enable view binding. What it does, it basically gets rid of find view by ID. Rather, it creates a binding class that basically allows you to then use your views in a type-safe manner by name rather than by code, by using the find view by ID, which can also return null, etc. This kind of does something similar as that the Android extensions for, or the Kotlin Android extensions do, where the Kotlin Android extensions also create these synthetic properties. There are some advantages of using this over the Android for the Kotlin plugin, etc. But view binding is a relatively new thing, but it's an interesting thing. But the main interesting thing here is the data binding, because data binding is kind of a more complex version. It's older as well, and it is really powerful if you want to use it correctly. So conceptually extends this view binding concept, but view binding bindings created with data binding are much smarter than view bindings. View bindings just tell you, well, here's a property, that's that view. Data binding actually gives you a binding where you can set a property, and then based on what property you set, the view gets updated. And not only that, you can have things automatically update if they are somehow data that can notify of change, something that's observable or has a listener attached, as we use in our assignment. So basically, what does data binding do? So it extends the layout language, the XML layout, and you can then declare data parameters. I will have some examples later. And in there you can specify values. And of course, Android Studio supports this properly, so you get code completion, all that stuff that you expect. So enabling it is very similar to view binding, except in this case we have data binding that we say it's enabled rather than view binding. Okay, let's see. So there's a question before I go to the next slide. So do we have any other form of assessment other than the dot and box assignment? Yes, there is an exam coming up. So the exam will be 30%, will be multiple choice online exam. I'm not sure exactly what the logistics of it are going to be, because it was intended to be a multiple choice in-person exam with just an answer sheet where you just tick some box, tick a pre-created answer sheet, but we will be doing that with Brightspace, or I have already transformed it into Brightspace, but the actual logistics of the exam will be something that will come later, so to speak. So I'm certain you will be hearing about that. When is the exam? There will be a timetable at some point published by the university. But that is normally after the lectures finished. So we still have 4 weeks of lectures, including this week. And that is the start of the exam period. I would be very surprised if it wouldn't be in the exam period. But we will be, I'll be trying to figure out how it exactly will work. And we'll tell you exactly what it will be. Anyway, continuing on data binding. So we've seen how we enabled it. Now we see how we use it. So rather than having our layout as the start of our design, we actually have a layout tag. Then that is not an actual element as you'd normally have in these layout files. We'd have this layout tag, and we have a data tag. And in the data tag, you can create variables. You can also create something like imports, by the way. And in that, using that variable, then you inside your layout, you can do things like you see here, where we actually have an add and then user.firstname. So the text that is used for this text view will be taken from this user. If you update that property, if you set a different user, it will also update these text views to have a new first name and a new last name. What it will not be able to do is say, okay, this variable actually can change underwater. So you need to set it again rather than just say change the property on the user. It won't be able to actually observe that this changed, unless you have something that can actually notify of that change. So that is the idea. So you can actually have your layouts take properties and you get values from that. And that makes your code in a way much cleaner, because in your code you don't need to think about, okay, how do I set this value? Okay, how do I do this changes, etc. We have in our layout, we basically say, okay, this is what it needs to display. What you do want to take into account there is that you don't want to put lots of complex code into your assignment. What you want to do is to keep these things simple. Keep the layout clean, and if you need a complex property, you want to make it work that way. And binding, so IDE support, there is IDE support for binding expressions, but it is still somewhat limited. But in general, it can get cluttered. So if you need to do something special, one of the ways you can do that is something called binding adapters. And a binding adapter basically allows you to also set complex properties on a view. So you can create basically a fake view property. That fake view property can then be assigned a complex variable, and then what you do is in that binding adapter you can say, okay, this will actually set this particular coded properties on our view. One thing to take into account is that it uses Java syntax, not Kotlin syntax, where it's different. It's not very different. So it has a ternary operator, so the question mark, then colon else, so where Kotlin uses if-else expression, it uses the ternary operator instead. It also, rather than the Elvis operator for question mark colon, Kotlin uses this binding expressions uses question mark for the same purpose. So if the value is null, does that. It does not have question mark dot. Instead, if you call null on call a method on a null property, it will just return null always. So it basically always does what Kotlin does with the question mark dot. Just something to keep in mind. Again, if you keep this simple, then it doesn't really go and hit you too much. And yes, the syntax differences can be a bit annoying, but they're easy enough to deal with. So how do you use these bindings? And there's basically, this is kind of what you want to do. You create, first of all, a data class. So a data class has users, etc. So this is the type that we're talking about. In this case, okay, we want to make sure it works correctly. So if we make first name and last name a val, we cannot change them. So if we have a new user with a new name, we are forced to set it again. That helps us with keeping stuff correct as well. And then when you're in your own create, what you can do is to actually create the binding. So the suggested way of doing this is just, instead of doing the regular set content view, you just use data binding util dot set content view. What that does, it is it basically sets the content view. So it does the regular set content view, but it also creates the binding. So now we have the binding. You might want to store the binding as an attribute in your class rather than a local property though. In this case, this is an example I got from the actual slide website. We just say binding.user equals test user. That's all. Of course, bindings can get much more complicated. We can have data bindings for collections. So yes, Android also has something called a sparse array. It's slightly different from what I have as a sparse array. There, if you don't fill anything in, it has a 0 value. It doesn't exist. So but the idea of sparse is that not every value is bound, the same as sparse matrix in the assignment. Anyway, so you can have imports here, and that makes the types available in other parts of your data binding. Yes, it's not 100% pretty, but we can live with it. And then we have the different variables. Yes, so the smaller than does need to be escaped, unfortunately. Those are the rules of XML. Again, live with it. And so you can have different variables, and then in the rest of your layout, you can make use of those lists and keys, etc. So, and yes, they do some magic to say, okay, actually the get method gets translated into an index access. As Kotlin does as well, by the way, only Java doesn't. So this is kind of how you can do those things. You can also actually use bindings to handle events. So you can set a listener, say an on-click. You can give it the name of a method, regular. That is the normal way. Data binding, you can use a method reference. So starting with the type name and then colon, etc. to do this. So when you give a reference, that means that when the binding is created, it will set that reference, and that will be what will be called when the event happens. You can also create lambda handlers, so lambdas, so inline functions. If you have a lambda that calls a method, that is only done when you're actually using your code. Again, the main rule there is don't put complex logic in your UI. There's tools available for accessing resources. So inside your data binding, you can also say, okay, I want to have some conditions. Maybe I have a different background if it's a super chat, whether it's a regular chat. So you can say, okay, if chat is super chat, put gold background, otherwise put regular background. And those backgrounds are just resource reference. Data binding will make that all work as intended. Much cleaner than if you have to do all this specific stuff inside your activity or inside a fragment. There's also ways where you can pass a binding to or pass stuff to an included layout, etc. If you want to know all the details, there's a lot of documentation available on the website, as I linked it in some slides previously. Then observables. There's a number of observable int, observable string, observable parcelable, observable many other things, classes. Basically, these are designed particularly for data binding, and these classes basically are wrappers for their underlying data type, and if you change the value, they will invoke a listener, and data binding knows about these types, so it will, if you set a property to an observable string, it says, okay, I know this is a special thing, so it will register itself to observe that object and update the actual set value. So it won't, and it will get the values out of the observable to actually use. However, these are a bit older, so this is before, so this was done already before the architecture components came into being. So there is also something called live data, which it also understands, which I would suggest you would use if possible. There's some other types that have a similar purpose that are automatically recognized by data binding. Then the life cycle. So our activities and fragments have different states, and there are some limitations. One of the things is, while an activity has a state, you cannot actually ask an activity what state it has. There are some, and actually recording the state has some really, really nasty, tricky bits in getting it correct without doing that properly. So what they have done is basically in the architecture component created something called a life cycle. If you use a compatibility activity, so activity compat or etc., then, or a compatibility fragment, it will automatically be enabled for life cycles. You can just ask for the life cycle, ask what the current state is, but also be informed if there is a change. So, and the states have been simplified a little bit. So as we can see in this diagram, which is a redrawing of the one on the website, there are 5 states: initialized, destroyed, created, started, and resumed. So initially, you're in an initially state. Then there's an event on create that is called when the application is created. This is where all the objects are already not the application, the activity is created. This is where you initialize your objects, etc. Make sure that you have a layout to display. When it's created, it is not visible. On start is when your activity becomes visible, but it's not active. So the started activity, you are visible, but not running. One of the things to keep in mind there is that you can often go from that the started and resumed states. So resumed is when you're actually running and live. But if you use two screen windows, which is an option in Android, you can display two applications at the same time. There's only one of those that is in the resumed state, and one is only in the started state. Sometimes, if you are not the active window, you want to stop processing. But for example, if you're a video player, people might want to watch your video while they are working on something else. So the video player should still continue playing the video if it's in the started state. So these are the various states that exist. And when you go on stop, you might want to stop things like playing video or trying to download something off the internet, etc. Or observing changes in a database or something that you may want to not do anymore. And then, so in on destroy, you do this. And then when you're in destroyed, you do that. So your component is never going to, is going from initialized to destroyed. And what about recreation then? Well, if it's recreated, you will, that particular object will go, and there will be a new object that will start in initialized state, but it may have a state passed along to it in its onCreate parameter or method. As far as lifecycle is concerned, it is still in onCreate, or it's an initialized state. So if you want to, so basically life cycles are there to help you react to these changes in what the state of your activity or fragment is. How do you do that? Well, you create something called a lifecycle observer. Lifecycle observer is a class that can handle these events. So how do you do that? Well, you put this annotation on a method that add on lifecycle event with the particular event that you are interested in. Which event do you say? Well, go back to the image. There's on create, on start, on resume, on pause, on stop, and on destroy. And yes, you can find this in the documentation. You see, documentation is really important on understanding this. So for these lifecycle events, I want to do something like, okay, I want to connect to a listener when we resume the thing. We want to, and when we pause, we are going to disconnect the listener, so we are not going to be informed when, say, someone finished downloading an image. Note that often you might want to have this observer be an inner class so that you can then, of an activity or something like that, then when you then react to the event, you just call in your listener, you call to something that is in the outer class. Opposite to this are lifecycle owners that are basically app-compat activity or fragment, but you can create your own one. As long as you have a lifecycle, you can be a lifecycle owner. It's a fairly simple interface. So anything that has a lifecycle, or that you can have a sensible lifecycle, you can make it a lifecycle owner, and it will exist for that duration. In particularly, a view model can also be a lifecycle owner, and that can have some. We'll come back to view models later. So yes, and of course, what you can say with life cycles, you can actually say what is the state. So am I active? Okay, then I'm going to play music. Otherwise, I'm just going to not do anything. And maybe when we resume, we will be told that we can play music. And then we check whether we can play music. But if someone presses play, something happens that says, okay, now I want to do it. I need to be able to check what the state is, whether I should be able to do it at that point in time. If you're downloading a video and you want to play it once it finishes downloading, you want to only play your video when you're actually in a visible state. Something like that. So live data. So a big challenge in these applications is that if some data changes from the internet or in a database, you want to actually update your UI, and you want to do that in an automatic way. We've talked about all this MVC stuff and MVVM and MVP. A lot of what that was about was to do this updating. So live data is a building block in allowing that to do with the MVVM approach. So what does live data do? Live data is a very, very simple data type. It holds a bit of data and it stores a callback reference to a function that is basically going to be called whenever that data changes. In addition to that, it is a lifecycle aware thing. So when you add an observer that will be linked to a life cycle, so your observer will not be called if that life cycle is not actually in a valid state. So it will only, say if you have an observer that says the name of a person, if that name of the person is already available, if the state of your component is only initialized but not started, then what will happen is it will just keep hold of this data, but it will not invoke your observer until the point where it gets to be in started state. When it's in the started state, it will then call the observer. So your rest of your code doesn't need to wonder about will my views exist and will it be initialized, etc. It will work correctly. So it will also retain this value. So if it hasn't been delivered yet, it will provide this again. So it keeps it around. Or if you change your view, it will actually have that data still available, so it doesn't need to re-download stuff again. There's quite a lot of cool stuff around, and I strongly advise you to also read the documentation as in the link. So that's what live data does. It basically informs through a listener or observer the data. And there will be an example of how this works later, but it actually, these components all interact with each other. So I have the example that is based upon this combination. So a view model. So a view model is basically a way to get live data. So what you want to do often is you have data that is shared between different parts with different activities or different fragments, etc. What you can do to deal with this is something called a view model. And the nice bit about view model is that it survives configuration changes. So if you rotate your screen, view model will stay around. And if that view model means that you're going to do quite some downloads over the internet or whatever, that is always a good thing to do, because it keeps your application nice and responsive. But we still need to make sure that if it actually disappears, we are also unregistering for listeners and not doing the internet stuff anymore, etc. So you can have your own, or you're providing your own implementation of view model. There's one requirement: a view model cannot have must have a no argument constructor. You cannot have one that has its own constructor. And it should not ever contain any reference to Android UI components. or state or code. View model is just about data, not about UI. It provides live data objects that are then consumed by UI code that says, okay, if this changes, do this, implement this. There is one particular subclass of view model that is called Android view model, because sometimes you need access to a context. You need access to resources. You need access, even for opening a database, you need to know something. And that is what Android view models do. But Android view models do not get access to the activity. So an activity is a context. An activity is a context that is related to a particular UI element. There is another context that is not linked to UI elements. That's called that's the application. The application is independent from UI elements. So if you do things like, okay, I want to do something related to my my screen density or my language or my theme, that does not work in an application context because the application does not have those properties. Just UI independent. But so if you make a subclass of Android view model, you can have one that has one parameter, which is an application object. This will be also constructed for you by default. So what does a view model look like? It looks like this. So we have a class, my view model in this case, that might have a private property users that has inside there is a mutable live data, and that usable live data is a list of users. And in this case, we make it a lazy property. So only when you ask for this, it will actually do anything. So when you ask for it, what does it do? Well, it creates this mutable live data, and then it will also, with that object, it will then also call load users. What does load users do? Load users but it has to be asynchronous. It needs to start some other thread because you want to return the live data immediately and then load your users. Also, this is an example from the website, but I would probably pass it along the actual live data object in the load users method so that we don't have any race conditions for when does it exist, etc. Although lazy should do this correctly. So, and in the get users function, we return a regular live data. So the UI code is not supposed to change the live data. Only the view model is supposed to change the live data. So if there's a new user, it will just call set data on that mutable live data, and then every object that is registered to that live data will then be changing according to that new data. Of course, you can also have an extension of Android view model, which looks like this. Basically, you just pass in the application and pass it along to the parent, and then you have access to the application through the get application method. So we have we have view models. How do we access these view models? That's actually quite easy. This is the Kotlin way of doing it. There is a Java way that is in the next slide. So the view model is created when the activity is first created. If it's recreated because you rotate your screen or something like that, or because it was kicked out of memory and needs to get back, it might still have that same view model if it existed, if it was not also kicked out of memory. So the easiest way in Kotlin is to use the by view models property delegate. Discussed delegates last lecture, so 3 weeks ago, 4 weeks ago, I think. Yeah, 4 weeks ago. that basically gets you that property in a nicer way. So that view model is retrieved through that method, and that view model is basically, we can get that, so it takes the type out of there, etc. So when we have the model, we can then get the users, and then we observe it with this lambda. So this is a typed lambda because it is view models are designed in Java, and it uses the single abstract method thing. So this particular syntax will create us a lambda implementation that also implements observer of a list of users. And then when we actually have data, it will call this lambda with a user's parameter of type list of user, and then you can update your UI accordingly. That's how that works. Fairly simple after you get your head around it. And so what does this look like in Java? Java is a little bit more complex because we don't have this delegate property thing. So there's something called there's KTX extensions for many of these Android libraries where they have some nice ways of doing things in a more Kotlin-friendly way where possible. And there's one for live data as well. And view models. So in this particular case, what you do is need to create a view model provider, and then based on that view model provider, you get the an actual instance of that type. So it's a little bit more writing, unfortunately. And then you can basically do the same thing with Java lambdas. So that's how you do it in Java. Kotlin is nicer. And you can actually also use live data with data binding. So you just have data binding that provides this particular data. So it is lifecycle aware. So your data binding will just, if you provide it a live data, it will do the correct thing. You can even make the view model a property that is available through your activity, available as a property in your layout, and then reference that view model to get all the different components. And one of the things I didn't say about data binding is that data binding actually has the ability to basically transform getters and setters into regular property access. So if it has a get user, you can actually just access it with user, even if it wasn't written in Kotlin. Kotlin does something similar for Java-based properties, but data binding does so. Okay. So that was the data binding bit and the architecture components. So before we go on to the next part, I would like to ask if there's any questions. Any questions at this point? So, okay, no questions. Oh, does it matter what coordinate system you use for the boxes and lines? For the assignment, it doesn't matter. You want to have something sensible. The coordinate system needs to be internally consistent because the tests do look at coordinates, but they don't care about their particular values. You can't reuse the same coordinate for 2 different lines or 2 different boxes, obviously. That will not work, but you can use whatever coordinate system you find works well for you. So if you want to really do the coordinate system in the way that I discussed with using it as so having one coordinate system for boxes, dots and lines, you could do that. It's in my head it's a headache of doing that. It's harder than using the 2 separate coordinate systems, but if you really want to, you can do that as well. It's all whatever you find works best for you. The assignment doesn't care, and from a marking perspective, only if it's something that's really dodgy would we want to do differently. So another point, by the way, for the assignment, that is start implementing the to-dos. There are many parts where, so the tests don't do only one property. Many of the tests hit a number of properties. So it's much more sensible to start implementing the game in a way that actually it should work. Think about what should actually happen here. What is the purpose of this function? And most of them are very simple. If you don't understand the purpose of a function, ask us. We'll be happy to help you. But the tests are there to check that it works correctly. They are not there to necessarily inform you about what the correct design is. And I found many students start with, okay, I need to have these tests. Sometimes people start implementing things and then they get less successful tests. Because some tests particularly kind of, it invokes a function, but if it doesn't do anything, it doesn't really matter for that particular test. So you might go down a little bit in the tests you pass. That's not very helpful. You can only really expect to pass the tests after you implemented all the to-dos. Many of them are easy. The hard parts are in things like draw line, where you need to make sure that you call the invoke run computer players. By the way, for computer players, you do use inheritance. To inherit from the computer player, you shouldn't be changing the player's file. But player is either a human player or a computer player. They are for your inheritance purposes, and because it's seal class, we know that it's only one of those two. So we can treat computer players specially and say, if it's a computer player, we will make them make a move. So if the computer has gotten a move, the expectation is that draw line will make this computer player make its move. So be aware of that. Then, any other questions? Okay, how do you get computer players to yes. How do you get them to take a computer player will also need to so if you look at the implementation of the computer players the turn thing, that one will actually, as long as the current player is a computer player, it will make it turn itself. So in draw line of the way to make this work correctly, if you do not have human players. By the way, this is not a requirement of the assignment because it's a bit tricky. But if that is the case, you do not, well, you only want to call the play computer players if the current player is a human player. Because that function that does the take another computer player turn, by the way, you can safely call it if the current player is a human player. It will just not do anything. But if it's a computer player, it will continue until there's no more, the current player isn't a human player, isn't a computer player anymore, or until the game is finished. So if there's only computer players, it will go to the next player. Oh, it's a computer player. Oh, it's a computer player. So it will continue playing those moves until there is no more, until the game is finished, and that condition becomes true. So to make that work correctly without exploding your stack, you don't want to call this function if the current player is a computer player, because you would always, the computer player is always invoked through that function anyway, so we use that loop. But again, this is not something that is required. If you call the play computer turns function and you are actually in a computer in a computer turn, it's fine as long as you have some human players around. If you have a human player, it will not become any problem with your application. Only you have no human players at all, will there ever be any issue with this. And in an Android game, it doesn't make sense not to have any human players. By the way, you can have 4, 5, 10 players if you want to. That should work. Be a bit odd how that works, how the gameplay works, but your application should be able to support that. Don't think I tested on that though. So, but yes, how do you take, so basically at the end of the drawLine method, you say, am I a human player? If I'm a human player and I don't have to repeat, and I don't get another turn, we call play computer turns. No, it doesn't loop. It doesn't loop through that player list only once. It loops it infinite times. Basically, it asks, what is the current player? Of course, when you are through the player list, the drawLine function needs to update the current player, including going back to the first one if the current one is the last one. The easiest way of doing that I find is basically just using the modulo operator. So something like next player equals current player index equals current player index plus 1 modulo players dot size. So this is the kind of function you would be using to set the current player index if you have such a property. Obviously, please be aware that I don't have the code in front of me right now, so names might be slightly wrong. I don't remember exactly what the names are that I used, but it should be fairly obvious which function I mean. Which property. Of course, current player index is a property that you're suggested to create, but it doesn't exist. So this is the easier way of doing it. You can also use an if statement if you want to, but this is slightly more concise. And it will go back to 0 if we are actually having too many players. So this is how you get to the next player. So it loops through all the players. So yeah, so the only thing is that you first need to call it once to actually start playing the game, because it doesn't start. Okay, with the UI implementation, so how do you determine the box position, the line? So the suggested technique for handling presses is basically determine which box your press was in. So when you then have a box, you've got 4 bounding lines. You can get that from the bounding lines property. And for each of those lines, you determine the midpoint. What is the coordinate in the middle of that line? So that determine, you need to basically use the view things that you know to know those coordinates. You have those coordinates because you needed to draw that line. You need exactly those coordinates. Then you have the midpoint. Well, it's a vertical one, it's, well, the half of the y. If it's a horizontal one, you do half of the x. Or you can do the average of the x and the y coordinates independently, whether it's horizontal or vertical, because it would just work. And then you just basically do the distance between that middle point of the line to the particular point that was pressed, and then you pick the one with shortest distance. And you may want to do things like, okay, if that distance is not overly longer than a certain size. In particular, if you want to allow clicks just outside the grid, you might want to allow that to work when you're not ridiculously outside of the grid. How do you do that? Yeah, well, you just set a maximum. Even if the smallest one is even too long, just ignore it. So that's so how do you determine the coordinates of a box or the lines? Basically, you have dot coordinates. So basically you need to figure out how long a line, how big the distance between two dots is going to be. The way that works is very similar to the way you determine the distance between two circles in the Connect 4 exercise. So you basically say, how much space do I have? How many dots do I need to put in there? Remember, or how many boxes do I need to put in there actually? Then I need to figure out how much extra do I need for my dots? And then you just do the math. You divide the available space by the amount of boxes, plus a bit of how big is a dot in terms of a box. And that's kind of how you determine the sizes. And you do that horizontal and vertical, and you pick the shortest one. If you want to make it really pretty, you then use that again to determine how big the size of your drawing actually is going to need to be, and you compare that with the size of your view, and then you can use an offset to basically, you can calculate the difference and half that, and then you can center what you're drawing into that view rather than putting it in the top left. And then you add the offset every time you need to coordinate. You do add the offset. And so yeah, so where's the dot? It's in the top left and the right, etc. So you just derive all the things from how big is your box, and okay, here's a box, there's a box, there's a box. If you struggle with it, I would suggest you take a pen and a piece of paper and you draw the things, and then you say, okay, suppose the width is 47 pixels or whatever. Where would be the coordinate between this line, this line, this line, this line? What's the coordinate of this line? What's the coordinates of the box, etc.? And it becomes fairly straightforward fairly quickly. So draw it out and then draw the things, and then so one of the things you want to do is you want to record those things as attributes in your view, because you need them for touching as well as for drawing. The perfect place to do it is in onSizeChanged, because anytime the size of your view changes, onSizeChanged will be called with the actual new size. So it's called onSizeChanged. If you calculate them there, then you will certainly have the correct coordinates. Any other questions? Okay, and I will go on to the adapter pattern. There will be other opportunity for questions at the end. So the adapter pattern. What is the purpose of the adapter pattern? So when we have code where there's often a case that we have some data, some type, of some instance of some type that we want to actually make work as if it was an instance of a different type or interface. Basically, so but we don't want to make a copy. We want to actually make it behave like that. That's what an adapter does. It basically sits around instances of type A and makes them implement type B, and using the underlying data. And this is a very quite common pattern that you'll find in a lot of purposes. And to see some example of this, for example, on this slide. So this is a very simple implementation. It's a string adapter that basically would say, okay, it will adapt basically a list of something. Basically, a string adapter provides a list of strings. How does this work? Well, when we use this, we just want to have an adapter, and then we do something until we have we go through all the indices and we print them, something like that. And we might have data that is an array of integers. And this array of integers, we want to actually make them accessible as strings. You can create copies, but in this case we don't want to do that. And in some cases, you really the underlying data might change, so that means that you want to update this. So an adapter pattern isn't casting. So a cast is when you're actually, so there's two forms of casting in Kotlin and Java. There's basically saying, okay, I have this data and I believe it is actually of that particular type. You tell the compiler to say, okay, this value, you think it's of type A, but I know it's also of type B, so I'm telling you it is also of type B. This means that that value actually needs to be of type B, or you get an exception. There's another form of casting that is what we call, actually in better terms, coercion. The coercion is when you what you do with integers or with numbers. So you say, okay, I want you to take this value and transform it into another type. Kotlin doesn't like that, but in Java you can take something like an integer and just cast it to string, and then the right thing happens. In Kotlin you need to call the right conversion method, because automatically doing those things has some problems in the design. So an adapter doesn't so much. So again, an adapter doesn't transform. So a coercion creates a copy of the value. It creates a new copy of the value that is of the coerced to type. A cast will tell the compiler that what I actually have here actually is an instance of the needed type, the type B in this case. What an adapter does is says, okay, I have this object that doesn't have its own state, but it will translate between the language of type A and the language of type B. So you can take an object, you can pass it an object of type A, in this case an integer array, and then it behaves as if it was a string adapter. So that's how it works. And there is actually another adapter in this bit of code. So when we go look at those types, and I put it very small, so I expect you won't be able to see them very well. But what we have here is we have another adapter, which is a string adapter iterator. Again, it's an iterator that exposes the underlying string adapter. So this is what you can do with Kotlin to make something. Oh, I want to allow for each over something. And to allow for each, you need to basically have an iterator operator. Or it needs to be implementing the iterable interface, but you can't implement an interface through an extension, but you can implement an operator as an extension. So Basically, we now create a string adapter iterator on this particular string adapter. So when we do that, we store basically what is the string adapter that we're working on. This is the adapted object. And then we provide the iterator interface or an iterator string. We need another property to make this work because iterators actually do have a little bit of state. Is what is the current one? So we store the next index. And when we then need to implement both the hasNext and next functions, hasNext we determine whether the index is still smaller than the last element in that adapter. Then every time we call this, we compare it with the size. So if that size somehow changed, the hasNext will also take that into account. Of course, this doesn't say you can only make it bigger. If you make it smaller, then all kinds of weird things may happen. You need to be very careful with changing data in the type that is actually being used somewhere else. That's an aside. And then when we call the next, we just take the string adapter, we get the string version with that particular index, and then at the end of it, we also increase this next index. So I use also here because to make it just tidy. I can use apply, but then I have a this object, which shouldn't really matter, but also is cleaner because then we just get an it that we just don't reference, and we also increase the index, but only after we get this. But the receiver of the also will be returned. And then you can have a slightly cleaner way of using this. And the operator thing will just create this adapter that creates an iterator out of a string adapter. So that's an adapter of an adapter. And yes, you can do that. An adapter is just a type. It's just a way of looking at things. So hopefully this is an idea of okay, you can actually change stuff. The recycler view type actually uses an adapter to actually feed it with data. But what is recycler view? So recycler view is basically a component that is used in Android to display lists of stuff that are the same. And it can display an infinite list. So if you have your emails and you're like me and you never delete any emails, you've got thousands upon thousands of emails. You could implement a scrolling list by creating a view for every email. That will, if you have 1,000 emails in your inbox, that will break. You will use a shitload of memory and it will be very slow to start your application. And why do you need to create 1,000 views when there's only 6 available for viewing? You don't want that. So instead, what you want to have is a thing that basically uses, in this case, even reuses views to displays items. So recycler view allows you, if a view is not visible, it wouldn't be visible, it won't even exist. But it will allow you to, or it will keep a cache of a few views around so that you can just, rather than creating a new view with the data, you will actually create a new view that will store this. You can be reusing a view because inflating a view is a little bit expensive, and if you're scrolling very fast through a list, that might actually be visible. In regular use, it's not that visible, but they want scrolling to be really nice and snappy as well. It is a better design. And so it supports an infinite amount of items because, well, if it's not visible, it doesn't care about it. Infinite is not correct. It supports the maximum amount of an integer, so that's about 2 billion items, because it has a size property that has maximum value, or it could be a long even. So in that case, it's, well, to the power 63. A lot. If you have that many items, you've got another problem. Many other things will break. So anyway, so we create the views on demand and it reuses them. How do you get these views? Well, we have an adapter for that because Recycler View is a generic component. It wants to allow you to display these items, but it doesn't want to force you to know what they should look like. People want to make their own way of making it look. That's what Recycler View does. So it replaces this list view class that does basically the same thing, not as nicely. Recycler View actually does animation properly. So if you add an item, it will actually animate the growing. If you provide, by default, it has a default animator. And you can define your own animations as well if you want to. Or if you remove an item, it can be animated automatically. There is a bit, so it's slightly more programming than list view because it is a little bit more opinionated, but it provides a lot of functionality for free. And it also provides a good way of doing this, including something called a view holder. Come back to that. So yes, there's a guide there, and I would suggest you, if you do this, for example, for a high score view or something like that, if you want to do that for your assignment, Recycler View is a good thing to look at. So it's part of the Jetpack, but so you need to add it to your project to make it work. Although Android Studio might be able to do this automatically for you. Obviously, pick the version that you need in particular, and use the Android X version. This is a slightly old slide that uses, so we would use version 29 in principle, but 29 no longer has the COM Android support library. It uses Android X Jetpack. So use Android X Recycler View, and then we don't need the V7 either. That's all gone. Use the modern Recycler View library. So then, so it has pluggable behavior. So you provide an adapter to make it able to get at your data. You can have your own layout manager. So Recycler View does also replace Grid View. The Grid View is if you have images in a grid, so you have more than horizontal and vertical. Recycler View also works horizontally, not only vertically, etc. There's different ways that it can work and different things you can do. You have a layout manager that does this, so most of the code is shared, and the layout manager determines what it looks like. And you can write your own one if you really want to, and an item animator provides animation. Getting back to the simple usage of Recycler View, you basically need to create an adapter. And important there is that there is this generic parameter VH, which is a view holder. And the idea is that a view holder is an object that holds a view, but also can have methods and properties. So you say, set this data to the view holder, and you just make it work. So a view holder is just that holds your view, and maybe some other things state that you want to add to this. In particular, you don't really want, for every time you have a view, do the find view by ID bit, etc., to get the contained views, etc., etc. Instead, you want a view holder, and then you can just set a property on the view holder. It also works really well with data binding, by the way. And then you have these three functions: get item count, that tells the view holder how many items there are to display in that list. And yes, if you make the list bigger, you can increase this, but you need to notify or call a function on the adapter to tell it that the data has changed. So you call notify, one of the notify method variants. Because Recycler View has different methods of being informed of that the data changed, so that it can do different animations depending on how it changed. And there is a utility that you can use if you if you don't know how some data changed, then you can use the utility to determine the changes. So yes, and the view holder allows you to store some information about the views or create a get setter method that you just pass data and then it updates all the bits. And you can make it quite elegant, and it's normally an inner class of the adapter, or at least not an inner class, a class that's defined inside the adapter. It's not mandatory, but common. So how do we create a view holder? So when we create onCreate view holder gives you two parameters. That is the parent and the view type. The view type, by default, it will just be 0. But if you have different types of views, you could override the getViewType method with the and that will with the index of the item that needs to be it wants to know what type it is, and then it will pass that along. So a view holder is something that holds a view, but there's no data attached to it yet. So this will just create your view holder. So you inflate your view, you then create a view holder with that view, and do this. So you call it a layout use a layout inflator to store this. You can get you might want to store that layout inflator in your adapter because you're reusing it all the time. And then we inflate that layout inflator. We inflate the layout with the parent. So it uses the parent to get the theming information. So what is the and for inheriting properties and styles and stuff like that. And then we pass it the false argument to say we don't want to attach it to the parent, because the attaching of the view holder to the parent is being done by the recycler view. This is in the documentation, but you must remember this. If you do this incorrectly, things will maybe work in funny ways. At the best, you get some flicker and make things slower. But you shouldn't attach it. So then the view holder, yes, can record stuff for your convenience. And so if you have a particular view that gets the username, you might have a username view and a message view or whatever you want. And you can record those, and then when you set stuff, you don't need to use find view by ID to get those. And this is a view that is, this view holder holds the view that is used for different things. A view holder also has a few extra properties that are helpful, so it knows what the current item is that is being displayed on, etc. So when we have the other one is onBind view holder. So what onBind view holder does is it takes a view holder and tells you, okay, now you need to update this view holder to make it display whatever needs to be displayed for the item at this particular position. So what you need to do is implement it, set the values, and make sure that also no old values from the previous item are visible. You make sure that you set all the properties that need to be changed. You say, oh, it's not visible, okay, set it to a null value, etc. And one of the things when we look back at data binding, if you have your view holder, you might just have it store your data binding, and when you set the item, you get that item. Oh, which is the item in that position? Okay, is this user? And then you take the binding and you say set user, and then it just updates automatically. So your view holder and your binding are almost the same thing at that point. That's something you want to do with adapters. Then view holders have some other, the recycler views have some other capabilities. There is a related library that allows for selection So if you want to allow selecting items, you can do it by hand, but there's also this selection library that allows you to do this. And a very cool one that I mentioned or I hinted at briefly before is this diff-util. Basically, if you have a list of 2 items and you want to know what's different on the list, diff-util will actually help you calculate this and invoke the notifications in the adapter. So the adapter will actually be able to make the right changes or approach the right changes. Of course, if you just add an item and you know you add an item, it's better just to call notify add item immediately, because that means you don't need to calculate and go through every item and compare them and do equality checks. Say this change, this change, this change, because that's what diff-util does. It uses a good fast algorithm for it, but obviously is not as fast as it would be if you had the item itself. So if you know what changed, so you can do that directly. So, and as most of the time when you change the list, you know what you're changing. Oh, I'm adding this, I'm adding that. But if you get something from a database, you might not. Those are the kind of cases that we have. And then we basically have questions. So any questions at this point? So if there's any further questions, I'll leave it on for a little bit. Otherwise, you can ask questions in virtual P201. Use the tagging, so tag @AP, then Kevin and I will know that it is related to application programming, and we will be notified that there's a question in there. Please stick to business hours. We have other things to do. So if you private message one of us, then we might actually be busy doing something else. So it's better to PM the application programming, and then we can both pick it up. Are there any other questions? Oh, okay, no more questions. Thank you. So yes, thank you for being there, for asking questions, etc. And hopefully this helps you a bit with the assignment, but most of the assignment stuff should be there already. And don't forget, draw things out. It makes your life easier. Okay. Thank you very much, and I'll see you next week for another lecture where I go into more language features of Kotlin.